Welcome to another codezing.org programming project. We're doing a level 3 project today, Tic Tac Toe versus the computer. So we've previously done versus another human player. This will be a little more complex because we're going to have the computer making decisions and playing against a human. The code is at codezing.org/tic-tac-toe. Let's head over to the site. And if you go to codezing.org, level 3, tic-tac-toe versus a computer. So it lets you pick whether you want to be X or O, and then from there it's a little similar, except that you will see that the computer is also placing pieces. So we put our X in the middle, they're putting their O in the bottom right corner. If I go there, let's see if I can beat the computer. It's not looking good. Nope. Last place. Alright, we ended up in a tie. So the computer's pretty good, but not unbeatable. It's mostly just making random guesses unless there's a block or a win. So you can certainly beat it. Feel free to see if you can. Down here we can get the Python code, so codes are getting longer, so you can either view it on your screen, and you can see it's a pretty long game now. We can copy it and paste it over in Spider. And let's take a look. So since I already spent a significant amount of time working through the versus a human player, I won't harp on a lot of that stuff again. We'll kind of quickly run through these individual functions that we've built into the game. So the first one is just creating a new board, and that's creating just a Python list with 1 through 9. Previously, the game would run one time, and if you won or lost, that was it. You had to kind of rerun the code to play again. This one will allow you to play again and again as long as you keep saying you want to play again. So this function will build a new board at the beginning of the game. The next one displays the board to the console, which is the same as the versus a human. Now here's a little bit of a more complex start to the game. Previously we just started with whoever was X placed a piece, and then whoever was O placed a piece, and it would switch back and forth in the game. This is going to be more complex in that we'll allow the player to decide whether they want to be X or O at the beginning of the game, and the computer will take the other side of that. So the first question we're going to ask the player is how many human players. So you can actually turn this version into human versus human as well, but if you don't want to, you can play against the computer, or I believe you can even put in 0 human players and it'll play itself. So let's look through this start game function. So in a lot of the games going forward, you'll see that I like to do this, the acceptable yes and acceptable no answers, and it just makes every combination that the user can enter that seems reasonable to me for yes or no, so that way they don't have to, if you say type yes or no, any version of yes or no will be sufficient. It doesn't have to be specifically an N or a Y or whatever. The code will accept lots of different choices. We're going to start by defining the X player and the O player as none, because we haven't assigned them yet. The next step is going to be determining how many human players. So here again I define what the acceptable answers are for the person to enter. So 0, 1, or 2. And we are going to start asking the player questions and making sure that their answers are acceptable, and then giving them feedback if it's not, and if they do give us an acceptable answer, figuring out what the right conditions are for continuing the game. So what's our first question? How many human players? So while question 1 is not in acceptable answers Q1, so we already said you can only enter 0, 1, or 2. Anything else that the user tries to enter, whether it be letters or a different number or whatever, will result in this staying in this loop. Right? So until they give us an acceptable answer, it's going to keep asking over and over, how many players do you want? It's going to try to set that to an integer, because we need an integer, not the string version of what they enter. If they fail to give us an integer, we don't want the game to die, to totally error out. So we're doing a try and accept. So try to set it to an integer. If that doesn't work, then just set it equal to none again, and it'll redo. So if somebody enters the letter A, this will fail. Question 1 will equal none, and it'll continue looping. If question 1 is not an acceptable answer, so if they do enter an integer, but it's not 0, 1, or 2, if they enter 99 or whatever, then it will print, it's not an acceptable answer, please choose again. If they do manage to set question 1 equal to 0, so 0 human players, then it's going to make X equal to computer and O equal to computer. Otherwise, it's going to need to figure out who is going to be X and O, so it'll go to the next step. So if the answer to how many human players is 0, we're going to get 2 computer players playing against each other. So at this point, they've entered an acceptable answer, and if they haven't entered 0, then it'll do the next step. So if question 1 is not equal to 0, so this exclamation point equals is the equivalent of not equal to. So like an equal sign with a slash through it, a lot of times is what you see, but in Python, exclamation point equals stands for does not equal. So we've seen before equals equals is does it equal, so does question 1 equal 0? This is if question 1 does not equal 0. So if it equals 0, we're going with 2 computer players. If it's not 0, then we need a second question. So our second question is going to be, would you like player 1 to be X or O? So the acceptable answers for that are going to be capital X and X, capital O and O. And it's going to test if question 2 is not one of these 4, then print out it's not an acceptable answer and ask them again. Right? We have the similar setup up here with the while loop. Until they give us an acceptable answer, it's going to keep looping through. Once they give us an acceptable answer, it'll break this loop and go to the next piece. If question 2 is X or X, this in just means if it's in this list, so it's including both, capital X or lowercase x. If their answer to question 2 is capital X or lowercase x, set X player equals to human 1. If it wasn't in X or X, then they must have entered the capital O or O, so else the O player is human 1. So now that we figured out is the first player X or O, we are going to figure out whether, or not figure out, but we're going to set the the human 2 to the right player. So if we figured out human 1 is X or O, down here we figure out that the other human 2, is X or O. And that's only if up here they picked 2 human players. So looking through this logic, if question 1, which was how many players, is equal to 2, and the X player is human 1, then O will be human 2. If question 1 equals 2, so same thing, if they want 2 human players, and the O player is human 1, then X player is human 2. So this step just sets human 2 to the opposite player, as long as the user wanted to play with 2 humans and not against the computer. This little chunk helps figure out whether the X or the O player is going to be a computer. So if we get through all of this, so let's say we chose 0 to question 1, then X and O are going to be equal to computer. If we chose 2 human players, then in this step we would have assigned human player 1 and human player 2 to either X or O. If we get all the way to this chunk of code and the O player is still equal to none, meaning it hasn't been set to human player 1 or 2, or it hasn't been set to computer already, then make it equal to computer. And the same thing for the X player. So kind of if default, if we've made it all the way through, this kind of captures the case that they entered one player and they assigned human player to either X or O. This will assign computer to the other player. And at the end of it, we're going to return X and O player. So at the end of it, we're going to figure out who's a computer and who's human 1 or human 2. And that will help drive the rest of the code, figuring out whose turn it is and what actions to take. The next function was covered in the first Tic Tac Toe. It's just going to ask the player where they want to place a piece. It's going to try to check and make sure that they're putting in a valid answer, and then return which place they picked. So when it prints out the board, they'll get choices 1 through 9. This allows them to enter that choice, does a little checking to make sure they're putting in a valid answer, and then returns placement choice. The check for win was also in the previous Python code for human versus human, and it's just going to check the board every time to see if either X or O wins. Each one of these if statements is checking whether they've gotten a win. So board 0 equals X, board 1 equals X, board 2 equals X is the top row of the board all equal to X. If it is, then X wins equals true. So it's checking all of the possible wins for X, all of the possible wins for O, and then if either X or O won, it's going to let the game know that there was a tic-tac-toe, that tic-tac-toe equals true. So at the end of this, it's either going to, if there's no tic-tac-toes, each one of these 3 variables will be false. If there is a tic-tac-toe, then tic-tac-toe will be true, and then either X or O wins will be true as well. So once this runs, you can figure out, was there a tic-tac-toe, and if so, who won. The next function was also in the previous video. It's just going to check for a tie, that all the squares have been filled in and nobody won, will result in tie game being true. This function was not, this is not in the last video. This is pick a random place. That's going to be for the computer. When the computer has to pick a random placement for their piece, that's what this function is going to do. So it's going to submit or pass the board variable, which is what spaces have been occupied already. And it's going to set valid choice equals to false. And while valid choice is false, it's going to choose a random placement for the computer to place their either X or O. And if that place on the board was already taken, or is not taken, then it will allow that choice to be true. So it'll try to pick a random spot to place it. If there's already an X or an O there, it'll choose again and again and again until it finds an open space, and then it'll return that choice to the remaining part of the code. So this picks a random place for the computer. The next function that we have is kind of running through the computer's turn. So this will pass current player, so who is the current player, and the board into this function. And it's going to go through and try to figure out whether there are any blocks or any wins for the computer to make. So that's going to be the first thing that it does. It's going to check for a block, and it's going to check for a win, and it's going to do those as priority over just picking a random place on the board. So this chunk of code, as it notes in the comments, will check for a block. So it looks for all the open spaces on the board. It's going to loop through 1 through 9, and it's going to try to place the pieces on this board and check for a win over and over and over. So it's going to say, if X is the human and O is the computer, it is going to check over and over and over and see, well, if the human gets to play again next and they place it in this position, will they win? And if so, it's going to say that's a priority. That's where we need to block. So this is going to loop through every placement. So it's going to check 1, 2, 3, 4, 5, 6, 7, 8, 9. It creates a temp board just because we don't want to overwrite the original board. We want to create a temporary board. And it's going to look through each one of the spaces, attempt to place a piece there for the opponent, and then it's going to check to see if the opponent would win. If they would win, placing their piece there, then the computer is going to preempt that and block. So it's going to try placing the opponent's piece in every position. If any of those result in a win, it's going to know that's where I need to put my piece so I can block. To check for a win, it's going to do a similar process, but instead of checking for whether the opponent would win, it will check and see would the computer win. So the computer is going to place their piece in each one of the 9 spaces. If any of them result in a win, then it's going to make that their choice. So it checks for a block first, checks for a win second, and then if there is no block or win, then it's going to run that function above where it just picks a random spot to put its piece. And at the end of it, it's going to return the computer's choice. So if it finds a block, that will be their choice. If it finds a win, then it would replace, even if there was a block, it will replace the block placement choice with the win placement choice. If it doesn't get to do that either, then it'll just pick a random spot. So block, check for win, and if neither of those can be found, then just place your piece randomly. The next function in the code is a simple, just kind of a query to the user again. So once the game is over, it's going to see if you want to play again. So it's going to say, it's going to set play again to true, and unless you tell it you don't want to play again, it will keep play again as true. So same thing, listing out what the acceptable answers are for the user to put in. That way if they enter something that's, they enter 99, if you ask them would they like to play again, it'll just loop through and check again until they put an acceptable answer in. So that's one complexity that we added to this code so that you don't have to rerun the code every time to play again. It'll, at the end of the game, ask you, would you like to play again? And you can just say yes, and then it'll rerun the code from the beginning. And then here is the main body of the game, the play Tic Tac Toe function. And you can see it's fairly long, but not nearly as long as it would have been if we didn't break the previous parts of the game into easier chunks. So this first part, start game, we had walked through before. Start game up here is just going to figure out who's which player, right? So start game figures out how many human players, how many computer players, and who is the X and who is the O. So we're going to start the game, then we're going to get a brand new board, and we're going to set game over to false because we want to loop through until the game is over. And the current player is going to be X, which is... So that's how you do tic-tac-toe. X goes first, I think. So the body of the game is while the game over is false, it'll continue to make decisions and place pieces. Once the game is actually over, there's a tic-tac-toe or a tie, then this loop will end. If the current player is equal to X, and if the X player is a computer, then it'll run that code where it does the computer's turn. It checks for a block, checks for a win, and then randomly places a piece if there aren't a block or a win. And then it updates the board to replace the number in that list with an X. And if the X player is a computer, it'll run the computer choice function. If the X player is not computer, that means it's one of the humans, it will run the function that queries the user of where they want to place a piece on the board. So this is if it's the computer's turn and their X, and this is if it's the player's turn and their X. It'll run the appropriate function. If the current player is O, it does the same thing. If the current player is O and the O player is a computer, it'll let the computer pick where to put the piece, running through again whether it wants to block or win or randomly place a piece. If the O player isn't computer, it's either human 1 or human 2, it will run the function that queries the user of where they want to place their piece on the board. Once the piece has been placed, then it'll check for a tic-tac-toe or a tie game. And if tic-tac-toe is true, it'll print out who won. If the tie game is true, then it'll print out tie game. And at the end of the turn, it'll swap from, if it was X's turn, it'll go to O. If it's O's turn, it will go to X. And that is one individual game. And then we have another function down here that allows the game to run over and over. So this new function will allow the play again piece to run. So that's play again to equal true. And while play again is true, it will play a game of tic-tac-toe. Then it will ask you whether you want to play again. If you say yes, then play again will be true and it'll keep running this loop. If you say no, it'll make play again false, and then the game as a whole will end. So a lot of little pieces. I'm sure you didn't imagine tic-tac-toe was so complex to try to program, but I would say probably half of this code is keeping users from entering bad information, right? And then the other half is maybe half of that half, 25% of the code is printing stuff to the board and kind of keeping things in order. And only a small percentage, if you think about it, a small percentage is really the artificial intelligence, the computer trying to figure out where to place their stuff. Because even these few lines of code is the artificial intelligence piece of where the computer is going to put their piece. Let's just run it. How many computer players? Let's try 0. Let's see if random is not. We forgot at the beginning of this code to import random. Import random. Okay, so name random is not defined. So for the random choice for the computer, we had to draw a random integer, and since I hadn't imported random, it didn't know what I was talking about. So going to need import random at the top of that. Try again. Let's try 0. There we go. O wins. The computer beat itself with O. Maybe you'd want, that kind of happened pretty fast. Would I like to play again? Yes. And how many players? 0. Be kind of neat if it printed out like the board after each turn. Maybe you can add that. If you figure out how to successfully add that to get it to show the board at every turn so you can watch the computer playing back and forth, maybe that'd be cool. And maybe it would just spit out a blur of boards and wouldn't be meaningful, but it'd be kind of fun to watch their decisions as they go along, blocking and placing their pieces randomly. Would I like to play again? Yes. Let's say I do 1. Let's see if I can beat the computer. Would I like to be X or O? I will beat X. And I'll do 5. And I'm not very good at X. If you haven't figured that out by now, I'm not very good at tic-tac-toe. Maybe you can give me some strategy hints in the comments, because I'm just not very good. I always end in a tie. I don't think I ever win. Even against this computer, I let my son play and he beat it right away. So, if you got any strategy tips for me, I'd appreciate it. Let's try human versus human. Make sure that worked correctly. Player 1 will be X, and so that makes player 2 O by default. And it obviously figured that out. So maybe I can beat myself here. 3, 7, 4, 6, 2, 8, 9. I tied myself. Alright, so I can't even beat myself. So it looks like all the stuff is working. Obviously, as you play through it, maybe you'll run into some bugs. Even the simple one like that first, you need the import statement, import random at the beginning. But feel free to play around with it. One of the cool things I kind of thought of was, you could change the X's and O's. I get a little tricky. I don't know. But maybe you can do that. It would take a lot of replacing all these X's and O's throughout to change it to maybe R's versus T's, or who knows what, exclamation points versus ampersands. But hopefully you had fun with it. It's a little complex, but hopefully you can see that we're trying to take a big game, break it into all of its little components, making separate functions for them, thinking through what the users might do to break the game. And some of that is you build it, you play it, you see what your friends enter in and watch them break it, and they go, I got to change that. And reiterating through that over and over, or iterating through that over and over until you have a game that's fairly robust and fun to play and interesting. Maybe you could make the computer better at picking spots. But if you have an improvement, feel free to email me the code at info@codezing.org. If you have something cool, we'll post it to the site. Like I said, comments after the video, or you can email me. But I hope you had fun with this, and we'll keep building more games, and you'll see they get more and more complex and more fun at the same time, I think. More interesting. But have fun coding, and we'll see you on the next one.